All right, here comes our fourth and final problem, and this one is definitely the longest. As you can see, we have three different rational expressions. We have to get them all to one side and do a common denominator. So like problem number 3, there's a lot of legwork we have to do at the beginning before we can start doing the inequality process of this. Okay, so let's start thinking about what our least common denominator is. This doesn't factor, but this does. This has a GCF of 3. So we've got 3 times 2x plus 1 here. So let's go ahead and identify our least common denominator. So first denominator is 2x plus 1. So we need that in our common denominator. Then we've got an x plus 3. We need that in there. And then when I look at this, the only thing that's contained here, that is not contained here, is that 3 out in front. So I'm going to throw a 3 out in front, and this is my least common denominator. Okay, so we've got to go through and figure out what are we going to multiply by, get it all to one side, and then go from there. All right, so this right here needs to be multiplied by both the 3 and the x plus 3. This guy right here needs to be multiplied by the 3 and the 2x plus 1. And this guy over here, well, he's missing the x plus 3, so we need an x plus 3 tacked on. All right. Okay. So I'm going to go through, I'm going to erase this line right here just so I have a little bit more space to work. Alrighty, here we go. So 5 needs to get multiplied by both of these, so it's really 15 times this. Minus. Okay, I have to do 2 times both of these, so 2 times 3 is 6 times that. All right. And then I've got that it is less than or equal to this, so I'm actually going to subtract that fraction over. So I'm going to subtract this, and then I'll have a 0 on the right-hand side. So I need to do 1 times x plus 3, so I need to subtract parentheses x plus 3. Put that all over the common denominator, which is 3, 2x plus 1, x plus 3. And because I've subtracted this to the other side, I have this symbol over here, and now I've got a 0 on the right-hand side. All right. We need to combine all of our numerators, keep the denominator in a factored form. That way we'll be able to easily identify our domain restrictions, okay? So we're never going to multiply out the denominator when we're doing this common denominator work. All right, so this is, let's see, let's do this a little bit shorter. We've got 15x plus 45 minus 12x minus 6, subtract x, subtract 3, all right? So that's what I get from all the distributing. Remember, distribute your subtraction signs. So now we're going to have this. Let's see, 15x minus 12x is 3x. 3x minus 1x is 2x. 45 minus 6 is 39. 39 minus 3 is 36. Over our common denominator of 3 times 2x plus 1 times x plus 3, that is all less than or equal to 0. We even have a GCF here that we can factor out. We can factor out a 2, make that 2 parentheses x plus 18. So I'm going to clean all of this up, move this up here so that we have a little bit more space to work. 1 second. All right, there we go. So I also went through and I factored out that 2 so that we have everything in a fully factored form. We're ready to identify, do we want positives or negatives? Okay, so we have our function here is less than or equal to 0. So again, the only way to make this function be smaller than 0 is to get negatives. So we want negatives again. Our domain restrictions from the denominator. There are 2 factors with x's, so 2 domain restrictions. That would be x equals -1/2 and x equals -3. Those are both going to be open circles as always for domain restrictions. And now we also want to take a look at the numerator equal to 0. That's going to give us numerator x equals negative 18. Now will that be open or closed? If you're looking at your symbol here, you can see that that's going to end up being a closed circle. All right, number line. Hopefully I won't forget to draw the circles this time, test values, and write our final answer. Here we go. Okay. So we've got three numbers. They are negative 18, negative 3, and negative 1/2. And we've got a closed circle at negative 18. Color that in, and open circles at the other two. All right. So, why don't you take a minute, pause the video, and see how far you can get with testing values. Okay? All right, here we go. Let's see if we pick similar numbers or not. All right, something bigger than negative 18. I'm going to do x equals negative 19. All right, and again, I'm going to plug it into the factored form so I can think about signs instead of actual numbers. So I'm going to have 2 times negative 19 plus 18, that'll be a negative, divided by 3 times, let's see, 2 times negative 19, that's definitely negative. And so is the next one. So I've got a negative divided by a positive is a negative overall. And that's exactly what we were hoping for, negative. Okay? So we've got our first one works out to a negative. Next up, I'm going to go with x equals negative 4. Okay? Keep in mind, there's no one right number to choose for your test values. And see how we have the 2 and 3 out in front? Those are always positive. They're not really going to influence anything, so I don't even really need them. So I'm just going to focus on the factors themselves, because remember, a positive times something stays the same. Positive times this stays the same. So I'll continue to write them, but they're not really necessary. If I plug negative 4 into this, I get a positive. Let's see, negative 8 plus 1 will be a negative, and negative 4 plus 3 will be a negative. I get a positive over a positive. Positive overall. Positive, no bueno. Don't keep those. Next step. All right, in here, I'm going to do x equals negative 1. Negative 1 plus 18 is a positive. Let's see, negative 2 plus 1 is going to be a negative. Negative 1 plus 3 is a positive. Got a positive over a negative. Negative overall. Well, we want negative, so we're going to keep that section. And now over here, I'm going to go with our favorite number in the whole wide world, 0. Almost always the easiest thing to plug in. Almost always. All right, so we've got 2 times positive 18 over 3 times 0 plus 1 is positive. 0 plus 3 is positive. This is all positives, which we do not want positives. So again, this one alternated. There was no guarantee. We had to do all of this work. We are ready for a final answer. We have 2 intervals. I want you to realize that you can have more than 2 intervals. You could have a single interval. You could have as many intervals as humanly possible. And you can have 2 intervals in a row that work also. I think that might happen on a problem or 2 in your homework. So again, when they don't alternate, you can have the same thing twice. All right, we've got negative infinity to negative 18. We can include the negative 18, but not the infinity. Unioned with, we've got negative 3 to negative 1/2. Both of those are not included. So here we go, guys. We have survived 4 examples of solving rational inequalities. All right, let me know what questions you guys have. I'm sure there will be a few. Good luck.